Welcome to Ask and Learn.
So we'll start off this podcast with some contextual learning. So solubility is the process of dissolution of a solute in a given solvent. So the solubility varies from solution to solution depending on their structure, their affinity to the extract, and the solute from various different solvents. So in the first part, so we have sulfur dioxide that is passed through water and comes out as bubbles, diffuses into the atmosphere. So the presence of SO2 in the atmosphere can cause irritation to the eyes, throat, and all sorts of different breathing problems, really. So in terms of solubility, Henry's law states that the partial pressure of the gas is directly proportional to our solubility of the gas. So our equation is CSO2 is equal to PSO2 multiplied by H. So here CSO2 is the solubility, PSO2 is the partial pressure, H is Henry's constant. So with the time SO2 concentration increases in the analyzer as more and more of the gas comes into contact with the liquid, so as a result sulfur dioxide is absorbed. So the concentration does keep on increasing until the point of saturation is reached. So if water was never changed with the time, then the concentration of SO2 would reach a saturation point with the gas, and the gas coming out of the bubbler would have 1000 ppm of SO2. So in the second part here, we're taking a look at Henry's constant. So we've looked at equations like this before, so all we're needing to do is calculate some mole fractions, some moles, and then so we get a value of 3.296 times 10 to the 4 millimeters of mercury per mole fraction. So in the third part, we'll start a fresh page here. So it's sulfur dioxide concentration, so that's SO2. Concentration is represented by square brackets. We have a value of 1.34 times 10 to the minus 4 moles of SO2 per litre. And then the moles of sulfur dioxide dissolved, 1.0 times 10 to the minus 4 moles of SO2. And the molar composition of air dissolved is 0.958 moles of dry air per mole. So the scrubbing solution is agitated or recirculated so that the composition of our sulfur dioxide will change and vary. So the base can be added to our solution so that it reacts with the absorbed sulfur dioxide, which would decrease its concentration.